Welcome to another teardown video. This time it's another Tektronix Type 184 Time-Mark Generator. So, what is it doing? As far as I can figure out, we got some trigger repeat times. 0.1 second. This point is really difficult to see if you're not using your best glasses. So this is 1 second, but what if the pulse is also 1 second long? So I guess we are adding those two times together, right? For the repeat time. That is what I figured out. But what if you take 1 microsecond pulse and 1 second repeat? Is the loop or is the period time 1 second? So that means this one is a little bit less now. I'm a little bit curious about what is doing. Also, is this an indicator of some sort? An oven? So maybe there's an oven for the oscillator or for the timing. But here there's also power. So now it's powered off, or is this just the output off? It's a little bit weird with that. And then there's a marker amplifier. So here we have positive or negative. Maybe this is for some trigger, maybe. I guess this is the real main output into 50 ohm. And look at that, 2 nanoseconds. Really? So that would be Bryce time, I guess. And then we can do a pulse width of 10 nanoseconds. Wow, that is fast. There's also trigger output, and there's a marker output. So now I'm a little bit. So this is trigger and this is, I think the best thing we can do now is try and power it up and see if we can figure out what it's doing and how it's working. Because we're not reading manuals. No, we want to try and see if we can figure it out. As always, before you power up stuff, look at the back. Fuse seems to be okay. It's set for 230, so that is great. That would be a regulator that is hot or non-isolated with a high voltage on it. So that is isolated. And what is that funny thing? Ooh, USA. Cool. All right. And it says maximum 55 watts. So that is what we should expect. And if it's a lot more, we should definitely turn it off. It looks like it is in a unit that is like inside an outer case of some sort. It's not that heavy. You can easily lift it with one hand, and it looks like you can unscrew this and then maybe pull out, see? The inner unit. So this one can be plugged into something else. Tektronix, alright. So I feel we are ready to power it up. Put in some signal cables, probes or inputs. It's 50 ohms and full bandwidth and all that things. So this is all in power off. And if it was set for 230, okay, let's give it 230 then. And let's power mains on. See? We have power usage. 36. Oh, it's getting up. And oven is lit. So what is the wait time? That is something we need to get back to. So it's 38 watts. And what are you doing? You're doing some pulses and stuff. Oh, every second it's doing something. But I thought it was off. How is that possible? What is that? I didn't ask for that, did I? Let's go to 2 seconds. Oh, half a second, right? So it's something is happening, and yeah, 1 second. Okay. Are we in DC on that channel? Yeah, our DC and DC, yes. Okay, so definitely we got some pulses going on here. So that is just fantastic. That's a little bit funny, isn't it? It looks like... Ooh, that is really... Look at that. Oy, something is not working if this was supposed to be working. This can't be good. Look at how much slippity slappity randomness. Where is the random funky generator? No, it's not called that. So what is that? There is something. Oh, look at that. The oven. Oh, it's on. Aha, so that means this turns on and off when the heater goes on. Oh, yes, look at that. So that is 38 watts, and then it is 24 watts for the heated something. Right? Okay, I will play a little bit more with this and get back. Okay, this can't be right. So the trigger is 10 milliseconds and the pulse is 10 milliseconds. And it's looking like that. That is the funky monkey. And so the purple channel is this output. And look, more stuff, less stuff, nothing. So what kind of output is that? And it's just, look at that, a sine wave. Really? And it's not even in sync with the other pulses. Now that is the weirdest. Okay, we need to try and put this output over here. And of course, that was a lot of signal, so. Aha, so there's a pulse and a negative pulse. All right, so that pulse works. Okay, great. So this is a marker pulse, and this other not in sync pulse for whatever that is doing. No clue. All right. Okay, now I figured this out. So that is a 200 megahertz sine wave signal. It is. I think there's something with a mixer in there that is not right, because look at that. There's some modulation. You can even see it here. Some funny kind of unstable stuff. It is not a clean signal. So I think we found at least two things that is not working, because obviously those pulses that are doing this blinkety flinkety here, that is not correct, right? So I think it's time for teardown. Don't you just love Tektronix? One screw and then yabba dabba do, out we go. Oops. Let's look inside. There'll be all the switches. Nothing fancy pantsy unexpected here. But look at that. Wow, man. We got some, you know what that is? This is silver solder wire on a little spool. So if you need to solder something in here, you need to use that solder. And there's a little note about that here. I love it. Here it says something about that silver soldering stuff. Huh? Here it says 1965, 500 megahertz tube oscillator. Isn't that just beautiful? I am in love. The most crazy, nice design, and all boards are gold plated, and all transistors, they're in sockets. Isn't this just fantastic? Wonderful design. Ooh, what is in here? What is that? That is something in a socket with a temperature and some. That is definitely something we need to look into. Maybe this is the oven of some magic pot. But I also found some crazy thing under here. I don't know if that is possible to see, but there is some kind of magic hidden in here. So we need to lift this board up and have a look. And the other side, that is some 200 megahertz. And this is why we were seeing some sort of unstable behavior. So there's a 200 megahertz filter mixer, something that makes this output 200 megahertz from something else. So this we definitely need to look into. And this is the bottom side of the oscillator. And the bottom side of the tiny tube sockets, and those are the ceramic solder points when you need to use a special type of solder. Wow, this is a brilliant example of fantastic fine engineering, countdown and power regulator. So it's doing countdown. There's something in this that is not working, I guess, because the timing was doing jittery, unstable timing. I don't know if it's a good idea to touch any of this if there's still voltage. So always be careful about that. Look at that, is a filter. 500 megahertz filter. So where is this 500 megahertz mixed with something else or filtered to generate 200? How is that done? And what is the whole idea about 200 megahertz output external? Or is this a time-based thing? Or where's it? Okay. So we need to go in and have a look and see what that module there was. Okay, it's not visible. Oh, here we can see. Here is the magic I was talking about. There is some sort of a secret module hidden there. Oh, it's beautiful with those tubes. Oh, and there's a magnetic coupling from the anode resonance circuit here to this is the... Oh, so that means this is not shielded in any way. So when now this is open, we will see a different frequency or something. And also I really want to open this one. So what should we do first? Pulling this one out of the socket actually explained exactly what this is doing. 10,000 kilocycles, right? So this is 10 megahertz of an oscillator in a nice plug-in module. But maybe we could just open it and have a look. So this is the internal part. Remember, this is from 1965. Here's a 68, so this is maybe newer. Or maybe this is just a serial number or something. But I think this is the heater. And maybe there's a temperature sensing device or maybe a little relay to turn it on and off, because this seems to be on-off temperature. And then there will obviously be a crystal or an oscillator in here. I think it's time to consult the schematics. But this is a beautiful device. This is the back side of the heated crystal. If you look a little bit careful here, you'll see this is a trimmer capacitor. So that reveals it is just a crystal in here. And the oscillator will be this tube. So there's a tube oscillator here. And maybe there's a buffer. So the signal goes here, and then a weak coupling goes to the next stage, or a buffer amplifier. I think we could just probe this with a scope. If we don't want to blow up the scope, we should be a little bit careful, because we could have some kind of high voltages on some of those tubes, you see. So I really would like to get this board out. Okay, those capacitors here. This looks a little bit... Maybe some of those capacitors are old and broken. Because look, somebody replaced one of the capacitors with a little flying electrolytic. So this, oh, you can even see the splatter, right? I think this reveals some kind of splat from the capacitor. So this one was serviced or repaired, or attempted to be repaired. I will go through all the components like this, and because I can feel there is something loosey, and just moving a little bit here on all the, maybe I can get a good connection, and maybe I could get a more stable output. With those tiny little tubes, I'm not really that super scared about voltages, because they're not running off kilovolts or anything. So I could easily put this meter here in the maximum range and just measure towards chassis. So the first capacitor here, -9 on its casing. Is this also minus? Yeah, okay, good. And this is +12. So the other one over here is -30 on its casing and +13 on its capacitor. And that one over here got -52 on its case and 134, 24, right? On its capacitor positive. So, okay, that will be the 4 different voltages to worry about. Have we got a lot of ripple or something on the high volts? Let's go in AC mode. Nope. We don't see a lot of AC on that one. Only 1. So that is completely normal. And here. 0. Ooh. Did you see that one? That is mains. So 0 point something. So we don't have a problem with ripple on any of the power supplies. Nope. So far so good. But we still have this unstable stuff, and I did poke around with all the transistors on this side. I think I finally figured this out. Okay, now we're looking at those 2 channels. And look, this is the 1 microsecond output. So if I go 1, 10, oh, that is unstable, right? 0.1. See, we got some unstable stuff here, but not in 1. That is the fastest. Then it is stable. Okay, so this is the other output. So if I put this in 1 microsecond as well, now we got stable operation, right? See, those 2 pulses, they are right, and everybody's happy. So let's change this to 5. See, and then it goes a little bit trippy. 10. Something is actually right, because you see, you get more and more distance, but it's not stable. So there's a counter, and I don't think this is actually the counter. I think this will be the amplifier from the different outputs of the counter. I think the counter is the thing that is under that board. So I think we need to go down there and have a look. And as always, when you pull stuff apart, remember to take good pictures of all the wires and their colors, and be sure when you pull these up, real careful not to bend or move them around. Also here we see some colored wires, and this one, we only got 3 wires on this side. So I need to pull up all those wires. Maybe I can just take out these 3 and then bend up the PCB so I don't pull out more than absolutely necessary, because it could be really cool to assemble this again. This is exactly what I was afraid of. Look down here. You see some thin, flimsy, sensitive wires coming out of this secret fancy module. Let's see if we can get a camera in here. No, I cannot. What exactly is that thing doing? Yeah. Let's see if I can show this. So all those different transistor couplings here and the delays from the previous pulse, that is actually what they call a counter, because it is a time out that prevent it from being triggered again, right? So the timing is just critical around this component. So if I touch this transistor, it's stable. If I remove the short, and if I touch the transistor, so it is just this, the components around this, that's a little bit inaccurate So of course this can be fixed. However, the 500 megahertz output here is not working. It turns on and off the voltage when you enable with this switch. So that is explained in the schematic how that works. But when this one is powered up, it is not generating the 500 megahertz, and that is why the fastest output here is not working, because that is needed. The 500 megahertz signal is needed for that. So, but all the other outputs, they are now nice and stable. If we go all the way up, and all the way up, and now next, no, yeah, here it is, from here. And of course, if this signal is unstable, it will also make the next one unstable, of course, because there's a random trick to the next one, right? So that one is the bad one, and all the previous one works. So that is how it works, and it can be fixed, and it was a lot of fun. It contains all sorts of fantastic things, and all the frequencies comes from the 10 megahertz. It's just multiplied and multiplied by all the different nuvistors coupled as resonant amplifiers for the harmonics. And it is really, really beautiful handwork. I really recommend downloading the manual. In some of those early manuals, you'll find some graphics. I think it is. Let's go back to the. Yeah, that is the nuvistors. They're explaining everything super detailed here. So that is the 500 megahertz and the filter, and yeah, it is really, really great. So you can always just pause this video and get access to this, but I do recommend downloading the manual, of course. Let's go down to the schematic, yada 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 yada. Look at that, huh? So this is what they recommend to to calibrate, and yeah, here you can see oscillator. That is exactly what I said, and those are the different amplifiers and filters and all that. I did find something that I wanted to show you guys from the schematic. Let's go. Where is it? Come no man. It is a beautiful manual full of all details. Don't you just love that? How detailed it is? And somebody hand drawn all this. Isn't it just beautiful? Okay, here is the explain of how it works. So the 10 megahertz oscillator, and there's a 20 megahertz doubler and a 50 megahertz multiplier, and then the amplifier and another doubler and another doubler, and so on. And this is the output switch that I was talking about, and this is the 500 megahertz multiplier that is not working.
I didn't really poke around too much with all the different couplings here. I think somebody just touched the U-shaped coupling in the input here, so there's no output. So that is what I think it is. But here it also shows the different frequencies that is going through all the different transistors. It is really, really good. And here we see the different pulses, and they go through those contacts, and then we have this output emitter follower transistors. This is mounted in the aluminium frame, and here, see, this is the 500 megahertz that is not working, and it consists of those U-shaped couplings here and here. Really beautiful with those two nuvistors. This is of course just a filter. Yeah, look, see what I'm saying? You'll find those funny drawings in some of the old schematics. And this is just because those schematics, they were really hand drawn. So they were sitting somebody and having fun with this all day long. And if somebody didn't talk to him for a long time, well, let's just make a little funny drawing. And they kept being in there. They are published, and you will find them now and then. And so here is the 10 megahertz crystal, including the heater, and so this is the oscillator, and so this is the two different tuned circuits for 50 and for 20. So the 20 goes here. Yeah, classic. I was trimming a little bit on this and optimizing for more output, and yeah, I could definitely do that. And here we see the different outputs, how they are going in and out and in and out all the way around. And so this box that I found on the bottom under this board, see, you'll see here, this is the delay line. And let's scroll. Here you see the other half of the delay line. See? It is slowing something down. So they're adding funny drawings. I love it. I didn't find those trimmers so I think this is they are indicating that you can adjust this this component, but I don't find this trimmer. So there's a logo of the guy who is doing the drawing, right? Maybe this is the initial, and this is maybe his number, employee number maybe. And then it just go on and on and on like that. So yeah, that was basically what I wanted to show you guys. There's not that much more fun to see in the schematics. It's just the same and the same and the same, with all the different outputs, blah 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 blah, and of course the classic power supply. And here you see the 10 megahertz crystal heater. So there's an internal oven thingy here, right? Ooh, be careful. So this is running off high voltage. And the regulated voltages, non-regulated, and yeah. All right.
There's a little follow-up on the nuvistors. They're really, really cute and tiny tubes. Almost, let's see, transistor sized radio tubes. That's pretty cool, huh? So this is the 500 megahertz oscillator. What I did is I unplugged everything here, and on top of those two nuvistors, we got this in a socket, so it's easy to lift this up. And the two anodes. Yeah, that's pretty cool. And I took those two and replaced one by one with the 200 megahertz oscillator and saw that they are both working. See, it's really easy to unhook the anode and pull them up just like that from the socket. So those are the more fancy nuvistors with top mounted anode. You can also find other type of nuvistors that looks like this with everything in the bottom. So, and they will also fit in this socket, but of course they're not gonna get correct anode connection. See, click, it's a standard